Hi folks, I'm John Dubasan, a librarian by day and a fisheries and wildlife student by night. Today I'm going to share an activity called Measuring Height of a Tree on Level Ground, which I created to use forests and forest measurements to teach students about trigonometry. I'll talk briefly about the target audience for the activity, some learning objectives that the activity supports, assessments you can use for the activity, materials needed for the activity, and the steps of the activity. The ideal target age group for this activity is high school students between the ages of 16 and 19, typically students in grades 11 to 12. Ideally, the students are enrolled in an advanced algebra, trigonometry, or other pre-calculus class. Learning objectives for this activity include the following. Identify the hypotenuse, adjacent side, and opposite side of an acute angle in a right triangle. Use a tape measure to collect accurate measurements of distance between an observer's data collection point and a tree. Use a clinometer to collect accurate measurements for use in determining tree height, and use knowledge of trigonometry to calculate the height of a tree on level ground. Assessments for this lesson can include things like students demonstrating hands-on use of the clinometer or measuring tape. In addition, the students answer questions along the way as they perform the steps of the activity. Now that we've talked about the target audience, the learning objectives, the assessments for this activity, let's talk about the activity itself, measuring height of a tree on level ground. So what materials do we need for this activity? Well, we need a forest or grove of trees. This can be trees around the school, trees at a local park, or even trees at a nearby forest. Since we're focusing on level ground, we need some of those trees to be on level ground. As for tools, we need a clinometer, measuring tape, preferably 100 yards, a notebook, a pencil, and a scientific or graphing calculator. Students should wear clothing suitable for working in a forest environment, like loose sleeve shirts, pants or jeans, hats, wet weather gear if needed. Sunscreen and insect repellent are highly recommended. Also, the instructor should have a basic first aid kit, a spare clinometer, and extra batteries. Extra is always good when you venture into the field. Now let's talk about the steps for this activity. First, the students are going to use their measuring tape to measure the distance between them and a tree on level ground. This will be in feet. Make sure that they mark the spot where they start measuring so that they can come back to it. Also, have them write this number down. Writing down the numbers along the way is a great idea for each of these steps because it's going to help them complete the activity. In addition, it will help you determine if any mistakes were made along the way. So that's our first step. Next, after the tree's been measured, the students will return to that spot that they just used to mark the distance, and they'll look through their clinometer and align that vertical line in the clinometer with center mass of their target tree. Next, they'll level off the clinometer by looking through it and ensuring that the horizontal black line, which is called the hash mark, is lined up to 0. They'll slowly move the clinometer up the tree. This is called scaling up, until the hash mark is at the top of the tree. From there, they'll record the value they see for the hash mark on the clinometer's degree scale, which is going to be on the left-hand side. They'll round that measurement to the nearest whole number and write that number down. So, they've just determined the angle of elevation. The cosine of this angle, angle theta, is equal to the adjacent side, which is our distance in feet, over the hypotenuse. They'll use a calculator to find the cosine of this angle of elevation, recording it to 4 significant digits. The cosine of theta is equal to adjacent over hypotenuse. Have them plug the values they have so far into this equation, and then rearrange the cosine equation so that the hypotenuse, which is currently unknown, is on one side of the equation, and the cosine of the angle of elevation and the distance are on the other side of the equation. To find the hypotenuse, they'll multiply the cosine of the angle of elevation by the distance. Have them round that answer to the nearest whole number. Now they'll use the sine function to determine the height of the tree. The sine of theta, our angle of elevation, is equal to opposite over hypotenuse. Another way to think about this is that the sine of theta is equal to our tree height over hypotenuse. So they'll use their calculators to calculate the sine of our angle, and they'll record that answer to 4 significant digits. Next, they'll plug the numbers they have so far into the sine equation. then rearrange this equation so that the opposite side, our unknown tree height, is on one side of the equation, and the sine of the angle of elevation and the hypotenuse are on the other side of the equation. To find the length of the opposite side, our tree height, they'll multiply the sine of the angle of elevation by the hypotenuse. Their answer here will now be in feet. We're almost finished. When the students took their measurement with the clinometer, the measurements were not taken at ground level. Rather, they were taken from head height. For our final step, have the students add their height, rounded to the nearest foot, to the length of the opposite side, our tree height, that they just found. This number is the height of our tree. So, we've talked about an activity called measuring height of a tree on level ground. We started by discussing the target audience for the activity and the learning objectives the activity supports, and assessments you can use for the activity. Then we talked about the materials needed for the activity: measuring tape, a clinometer, a pencil, a notebook, and let's not forget appropriate attire and batteries. Wearing the wrong stuff can make for a long day in the field. Finally, we talked about the steps of the activity. While this activity focuses on measuring height of a tree on level ground, it is much more than that. The ultimate goal for this lesson is for your students to have positive learning experiences about math in an outdoor setting. After all, the students you teach today are the students who are going to be adults responsible for the environment we all love. I'm John Dubasan, and thanks for listening.